All right, go ahead and pause and do the homework check. We are doing chapter 6, lesson 3 and 4 in one lesson today because they're all dealing with elimination, and so we'll just be doing them together. Go ahead and pause here and take these notes down. All right, starting with number 1, looking at it, we know that it's going to be elimination in order to solve these. Remember, there's 3 ways to solve 2 equations, 2 variables. We've done graphing, we've done substitution, and now we are focusing on elimination. So on number 1 here, I'm noticing that the y's have the same coefficient, which is 1. The x's do also. However, I know that in order to cancel them out, whatever variable I'm looking for, one of the coefficients needs to be a positive and the other one needs to be a negative. So when I'm going to combine like terms here, 1x plus 1x equals 2x. They won't cancel out. But positive 1y and negative 1y combined together, those will cross out. So y is the variable that's going to be eliminated in this problem. And then negative 4 combined with positive 2 would be negative 2. Now we have just a simple equation. We can divide each side by 2, and we know that x is negative 1. So I'm going to go up here and put that here. And then it says take that information and put it back into the top equation. So instead of writing down x plus y, I'm going to do negative 1 plus y equals negative 4. Add 1 to both sides, and I get y equals negative 3. So if I were to get number 1, both equations into y equals, and graph them, I would find the 2 lines crossing at negative 1, negative 3. If I were to have subtracted y from the first one and gotten x by itself, and then used substitution, I would have found the answers to be negative 1, negative 3. So any way you do it, you're going to get the same answers. There's just 3 different ways to solve it. So looking ahead at number 3, I'm noticing that the x's both have 3 as the coefficient, and one is negative and one is positive. So when I go to combine them, they will cancel out. So I have 3x minus 1y equals negative 9. Negative 3x minus 2y equals 0. So those, when I combine them, will cross out. Negative 1 combined with negative 2 is negative 3. And negative 9 and 0 gives me negative 9. Divide both sides by negative 3, and I get y to be 3. I'm going to put that back into the top equation. So instead of 3x minus 1y equals negative 9, I'm going to do 3x minus 1 times 3 equals negative 9. So 3x minus 3 equals negative 9. Add 3. 3x equals negative 6. Divide by 3, and x equals negative 2. Now, what do we do if, looking at number 10 here, I don't have matching variables, coefficients? So what I'm going to do is I'm going to multiply one of the equations, or sometimes you need to multiply both equations, by a number in order to make them opposite. So if I'm looking here at my x's, I have positive 6x and positive 2x. Now I know I'm going to need one of them to be a negative, and I also need to make them matching coefficients. So if I multiply 2x by negative 3, then my coefficients will be 6x on the top and negative 6x on the bottom, which will cancel out. However, whenever you multiply by a number, you have to multiply it to the whole equation. So that's why I wrote it kind of like a distributive problem. So my top equation is going to stay 6x minus 3y equals 21. And now my bottom equation with distributing is going to become negative 6x, negative 6y, equals negative 66. And the biggest problem I see with this is people forget to distribute to the number behind the equal sign. So normally if you have a decimal problem, you get something that doesn't look right, it's usually because you didn't continue to distribute all the way across. So now when I go to add like terms, those will cancel. I have negative 9y equals, 40, my goodness. 21 minus 66, 45. Divide each side by negative 9, and I get y to be positive 5. Now that needs to go back up into the top equation. So I'm going to have 6x minus 3 times 5 equals 21. So 6x minus 15 equals 21. Add 15, so 6x equals 36. Divide by 6, and x equals 6. Looking at number 11, I again see a 2y and a 6y. They're pretty close. So once again, I would take the top equation and multiply it by negative 3, because then that would give me here negative 6y. So the top one's going to become negative 9x negative 6y equals negative 33. And the bottom one's going to stay 2x plus 6y equals negative 2. So those will eliminate then. So then I have negative 7x equals negative 35. So x is 5. Put that back up into the top equation. So I have negative 9 times 5 minus 6y equals negative 33. So negative 45 minus 6y equals negative 33. Add 45. Negative 33 plus 45 is 12. Divide by negative 6, and so y is negative 2. Okay, let's move on to applying it to word problems. So when we get down to these, what we're going to have to do is write our own elimination problem and then be able to solve it from there. So this one says 8 times a number, so that would be 8x, plus 5 times another number, so plus 5, another number would be y, is equals negative 13. Then for my second equation, the sum, which means to add the two numbers, so add the two numbers, okay, so x plus y is 1 equals 1. All right, so in this one, I could go for either variable. It doesn't make a difference. I'm going to go ahead and multiply the bottom equation by negative 8. So my top equation will stay 8x plus 5y equal to negative 13. And my bottom equation will become negative 8x, negative 8y equals negative 8. So my x's will cancel out, and when I do that, I'm left with negative 3y equals negative 21. Divide by negative 3, and y is 7. Put that back into the first equation. So 8x plus 5 times 7 equals negative 13. So 8x plus 35 equals negative 13. Subtract 35 from both sides. So 8x equals negative 48. Divide by 8, and I get x to be negative 6. Let's go down here. Gunther invested $10,000 in 2 mutual funds. One of the funds rose 6% in 1 year, and the other rose 9% in 1 year. If Gunther's investment rose a total of $684 in 1 year, how much did he invest in each mutual fund? So we're starting with the first equation here. $10,000 into two separate funds. So we don't know how much is in the first, plus he added some more to the second, but he knows it was a total of $10,000. The first fund was 6%. We cannot put percents into our calculator, so that is 0.06x. Plus, the second one was 9%, so 0.09y equals $684. I'm going to multiply the top equation by negative 0.06 because I want my x's to be the same coefficient but opposite signs. So that would give me negative 0.06x, negative 0.06y equals negative 600. And my second equation stays as 0.06x plus 0.09y equals 684. So those will cross out, and I'm left with 0.03y equals 84. And 84 divided by 0.03 is $2,800. Now I put that back into the original equation in the y spot. So I have x plus 2,800 equals 10,000. Subtract 2,800 from 10,000. And I get $7,200 for x. Okay, so you notice you have two lesson assessments here because the first one is just when they already give you the two equations so that their coefficients are opposite signs. And then the second one is having to multiply to make them that.